Okay, folks, show you what we're doing here. We've got frozen pipes. So we've been working for the last little bit to try to get them thawed out. And I thought of something. We've got heaters on the wall, like all these different things, but everything's buried in the wall. This is Texas. We don't have them well insulated. So what's the issue, right? The pipes, the copper pipes are frozen in the wall on the north side of the buildings because we've got negative 17 feels like temperature. So a lot of people are experiencing this right now in the center of the country where everybody's hitting this crazy cold front. I'm a home brewer, so in addition to all this farm and homesteading that we do, I brew beer, and one of the things I have readily available is a sump pump that I have converted into a keg cleaner. This is goes up inside of my kegs to clean, and then I also have fittings that go onto the keg itself. So there is a liquid line ball lock fitting, or excuse me, that's the gas line. The liquid line I cut off so that I could insert this into the faucet here. Took the tip off the faucet so there's no filter. And what I've done is submerged the sump pump into water that we did have that was warm, that was able to be transferred from our other faucets that weren't frozen. And I have intentionally left this with a diameter that is an outside diameter of the hose slightly smaller than the inside diameter of this faucet. And the reason why is thermodynamics. So we're going to try to flow water up straight into this with one of these valves completely open. So we already flowed the hot water, and just recently our hot water is now able to flow. Works fine. So hot water is working great. Neither of these faucets were working before. You can see the cold water still not going. But what's going to happen is as we run this liquid line up inside the faucet, there is cold ice on the other end of this line up to a certain point where it's not frozen anymore. So thermodynamics says we're going to run hot water to the edge of that ice, but because we're allowing it to flow back around this hose, it just creates a pocket full of hot water on the edge of the ice. It will slowly start to melt back the ice as the ice bleeds its cold to the hot water, but you're dumping that hot water right back here in this pump. This is a sump, or excuse me, yes. This is a pump that actually creates a little bit of heat. So we've got it set in a way where it's going to be, able to recreate heat as it's going. Some pumps don't create a lot of heat, and that's fine. You don't need extra heat if you can heat the water on the stove or something like that. We could take this water that's probably about 100, maybe 110 degrees. We could take this water and boil it on the stove and get even better production out of that, because the hotter the water next to the ice, the faster it's going to melt. But this is just recirculating water, and it's just going to keep replacing that cavity of hot water between the ice, and it's going to go further and further and further. The waters and the ice are going to blend temperatures, and then that water is just going to come back out, and that ice will continue to slowly melt, and slowly melt until it reaches the other end where it's hopefully not frozen anymore. So hopefully this helps you guys. This kind of a pump is pretty easy to come by. You can go to Harbor Freight or Home Depot. Everyone's going to have a small pump. You would like a little bit of flow, so this is a sump pump that has, I believe this is a half horsepower. I mean, you can get as heavy duty as you want, but you're going to have to reduce it. So most of these pumps are about a 2-inch or an 1.5 inches. You're going to have to reduce that down to a hose, something along these lines. You can do that with PVC fittings. And the more power that you have there, the faster you're going to flow water and replace it. I don't think the flow rate is all that important in this situation. You just need the pressure to push it through your pipes. So you do want enough power for that. So this situation can be remedied here pretty easy. And we're hoping that now that we know that the north side of our house is going to freeze, we'll do a better job about running water probably overnight through this at a little faster clip, because people say, well, you want to run it dripping. Well, if it feels like negative 17, your dripping needs to be a little more of a solid flow, or else you're going to freeze the pipes again. So that's what we got. Hopefully this helps everybody. Appreciate it.